Sessions left. This one should be excellent, as Alexandra is going to be doing a panel with Adam Back and Giacomo Zucco covering, reflecting on scaling 5 years on. So this should be excellent, and I think we're very lucky to have all three of these together. So let's give them a very, very warm round of applause.
Hi, everyone. Welcome. Thanks for coming to our panel. So my two guests here, I don't think need much of an introduction, but just in case for the live stream, we're here with Adam Back, who's a famous cypherpunk applied cryptographer, the inventor of Hashcash, co-founder and CEO of Blockstream, and Giacomo Zucco, who is director of BHB Network, co-founder of B Academy, which is a new education initiative, and a accomplished Bitcoin entrepreneur since 2013. Welcome.
Thank you.
All right, so we're here to talk about scaling, reflecting on scaling. A lot's happened. It's been a very contentious topic. So within the past 5 years, I'd like to know what some of the highlights are that you've each seen in Bitcoin over the past 5 years, and what surprised you?
So I think that there's been a lot of active development during different cycles of the market and throughout the period. So I'd say one thing that's very positive is the sort of pace of innovation, the number of new developers getting involved, a new number of wallets, with different layers, like the emergence of Lightning during that period, becoming available in an increasing number of retail wallets. So I think the positive and surprising thing is the pace of innovation, and that new and surprising technical possibilities are arising even today. After Bitcoin has been running for over 10 years, it's evident that there's still very exciting prospects for breakthrough innovations.
For me, there were mostly two surprising things in the last 3 years, I think. And the first one was related to Lightning and layerization in general. When I first approached Bitcoin, as many, I was completely clueless about most of the trade-offs. And when knowledgeable people like Lawrence, Naum, or Blockstream, my Bitcoin mentor, started to explain me trade-offs and problems, one of the problems was scalability. And looking at the numbers back then in 2013, the problem was ugly. And I remember reading Al Finney coming up with the notion that Bitcoin cannot really scale at the base layer for casual, everyday, random payments, because it's a global consensus system, and so it has to record every transaction of everybody forever, which by definition cannot scale. So the obvious answer, which was not so bad anyway, which was also what Saifedian told about, it was the Bitcoin banking answer. So the base layer will be free and permissionless and trustless. There will be some trusted layer on top that will not be great, but still will be better than what we had, because getting your gold from a central bank is quite expensive. Germany is still waiting for the gold from US, while getting your Bitcoin on chain from a trusted entity is better. So it will not be so bad. When Lightning started to come out as a real alternative, payment channels and routing through payment channel, for the first time we could see a possible solution to the scaling problem that was not as bad as the custodian solution, and not as clueless as the just make block bigger solution. And the second thing that was surprising me was that I was used to see cool projects killed by corporation cartels and regulators. So yeah, this is cool, this mesh network, this anonymity project, eGold, the Second Life. There is a lot of projects that are cool, but then eventually a corporation cartel or a regulator will come and will ruin everything. With Bitcoin, I was still used to this mindset that when big players start to weigh in, they will win. So when I started to see the miners cartelizing against Bitcoin, or the most payment companies creating a cartel in a New York agreement attack and attacking Bitcoin, I was like, yeah, okay, this is the moment in which the big guys will will band together in order to attack, and they will create damage. And they basically lost, which is great.
So on the topic, how real of a threat was SegWit 2x? And what other features currently being discussed do you think we should avoid, and why?
So, I mean, I think at the time there was a lot of uncertainty about what would happen with SegWit 2x. There was much misunderstanding about the game theory. And you know, some people really thought that miners defined the protocol, which is a sort of technical misunderstanding, because there are many people running full nodes. We know approximately from, I mean, not all of the full nodes are directly reachable on the network, but you can tell, you can infer from statistically from the ones that are and their connection statistics that there are around 100,000 nodes, which is a lot of nodes, and that many businesses and exchanges and wallets are very definitely running nodes or multiple nodes. So it turns out that you know, the idea that miners would define a protocol is very, very incorrect, because people who are economically transacting are looking at the information from their node as an arbitrator. So, you know, if somebody gave you a coin and your full node says it's not valid, well, then you didn't get paid. So you would go back to the person who sent you the money and say, this isn't a valid coin, and they would look to the miner and say, well, what is it that you're trying to sell me here? So ultimately, miners are, it's kind of like, you know, miners are digging holes or digging up some raw material from the ground, and if it turns out that that's not what the market wants to buy, they will quickly stop doing that. And so, you know, in the SegWit 2x episode, the people in the companies that were trying to organize to push Bitcoin into a kind of bigger block, more retail payment direction, spent a lot of effort lobbying miners with the idea that the miners were the decision makers. But it turns out the miners were basically powerless and immediately switched networks, just for simple economic reasons. And so I think the combined learning for everybody that the end users with their economic voting, you know, that they would sell the fork, they would short the future, and that the miners were basically not politically active in any way. They would just mine whatever's more profitable, meant that it was kind of a landslide victory for people who wanted to keep Bitcoin as a user-controlled and owned currency. So the fact that that worked was extremely positive. So as Giacomo said, that you know, people were nervous before, but when it was a victory, and it was a genuine grassroots victory, which showed that the developers had essentially no control, the large companies had no control, and the miners had no control. So it's basically a perfect storm, and Bitcoin came out the other side completely unscathed. So people view that as a very interesting and positive lesson about the sort of long-term store of value capability of Bitcoin, because basically all the forces that could be potentially aligned against the user's interest to keep Bitcoin permissionless and decentralized tried their best to coordinate and completely failed in the market. So I think that was instructive to everybody, because people were kind of nervous or unsure, had different levels of understanding about the game theory. But it turns out that basically it's not possible to change Bitcoin if you have your own private keys and you wouldn't accept a transaction that's not verified by your full node, then other people out in the world can do whatever they want. They can mine other things, they can make arguments, they can change the software their exchange runs, but ultimately you're still going to have Bitcoin, and nobody external to you can change that fact. So that fact was not understood. And I think that's also very positive since then, that there's been a lot of interest in adopting full nodes, multiple new companies building full nodes, making them easier to use. So I think that's an important object lesson, because if you were not running a full node, you would have been potentially vulnerable during that kind of protocol turmoil period.
Yeah, I completely agree with Adam. The entity of danger of the New York agreement attack was not clear back then, and inside now it's very clear. The point is that we have two different concepts of security model for Bitcoin. One security model for Bitcoin, which is the actual security model of Bitcoin, what your Bitcoin node will do, what even the first Satoshi client will do, is separating the act of validation from the act of confirmation. So your node independently, without asking anybody, will be able to say if the blocks and the transaction are valid or not, following the rules of Bitcoin. And they don't need any kind of hash rate for that. Validation is about signatures, about inflation rules, about block size, etc., etc. And the second rule is confirmation. So what your node does is it checks if the transaction is valid or not. If yes, it enters the mempools. But then if there is a block including an invalid transaction that has more hash power than more proof of work than other blocks, if it's invalid, it's still invalid. Your node will reject it. So the miners are not validating, they are just confirming, and they're giving you the chronology, while your node is giving you the validity. This is the Bitcoin security model, which is like dualistic, with the miners only committed to do one thing, which is unique chronology and not validity. Then there is a second security model, which was existing mostly in a narrative of people who misunderstood the real security model, which is actually the miners are doing everything. If they decide that there is inflation, there is inflation. If they decide that your money is spent, it's spent, which is not how your Bitcoin node actually works. It's not how the code works. But the scary things about the New York Agreement attack is that for a moment it looked like the fake security model, the misunderstanding generated security model was actually real, in that many people, a big part of the economy was not running node but just trusting the so-called SPV model. So SPV is a very strange name. Basically, SPV was an idea by Satoshi, a very advanced hypothesis, which was like we could even switch from the first security model to the second, provided that we invent something called fraud-proof, distributed fraud-proof. And nobody invented this distributed fraud-proof because they're possibly not even possible to invent, because there are several theoretical problems to do that. But still, some people that we don't want to name here, like Mike here, created something that was actually the second security model. So you trust the miner completely without validating anything. And they called that SPV as a reference to Satoshi's idea that was never actually implemented. So if the New York Agreement people were, they actually, if you go back in the text of the slacks of the New York Agreement implementation, BTC1, they were actually celebrating the fact that everybody was running SPV wallets. So they said, I don't remember who said that, but they said publicly, it doesn't matter what Bitcoin client does. If enough people is running SPV wallets, if we change the rules with the miners, they will have to follow, the economy will follow us. So in hindsight, we understood that most of the big actors like exchanges and whales, hodlers, they were running nodes. But still, some people like Luke Dashier is concerned that the level of validation weighted for the economy is too low, and that's still possible, so we should always be aware of the menace of this kind of attack.
Yeah, I mean, just briefly, I think the other problem with the New York Agreement was, other than the change they wanted to bring, which was to basically optimize for their business model, and maybe not in the interests of the users in the market. You could see that reflected in the price, basically. That their fork future was 10%, and now the remaining forks are like 2 or 3%. But nevertheless, a big part of the problem was the process by which they proposed to make a change. So they proposed to have, well, actually had a meeting with a dozen people who represented big companies in a hotel room during the Consensus Week in New York in 2017. Said, okay, we'll decide what to do, and that will be Bitcoin. And basically, Bitcoin said, no, that's not acceptable to us. So we don't care what you say in your hotel room, and Bitcoin is going to continue to be Bitcoin. So even if there was a proposal that Bitcoin wanted, if it was to try to be imposed in this way, that would be unacceptable. So I think that's because people expect that a change should be opt-in, and that there should be widespread agreement amongst every corner of the ecosystem before it would even be considered to be adopted, and that it should be backwards compatible. So another problem was this fork was not backwards compatible. It was a hard fork, which is something very difficult to coordinate without creating a big split in the network and incompatibility and a huge mess.
So we are running short on time, so I'm going to skip to the last question. If we have time, we'll go back. Do custodial services play a role in scaling? And if so, what are the benefits or challenges of these being used for people to transact off-chain?
I mean, they are effectively, and have been for many years in the sense there are a lot of people who keep funds on exchanges or in custodial wallets. I would argue that it's far better to keep your own money and keep your own keys, run your own full node. But, you know, if you are maybe spending, you know, the amount of money you would keep in your wallet, like a few tens or hundreds of euros, that using a custodial service is, you know, maybe not a big risk that you need to worry about. But fortunately, we have this new technology in different layer 2s, like Lightning, which can support a kind of hybrid model where they're still your Bitcoins and you can still assert ownership of them, but not all of the transactions need to go on the chain. You know, maybe only 1 in 1,000 or 1 in 10,000 needs to go on chain. And there are other layer 2s, and I think the innovation in layer 2 is not finished. So I think in the future, we'll see more creative ideas for layer 2. So Liquid is a kind of layer 2, and there are other examples of sidechains which is optimized for exchange traders. So maybe they will less clog up the main chain with trading activity, do that in Liquid and leave the main chain for its advantages, being long-term storage, sensor-resistant payments, and sort of things that require asset protection and self-sovereignty. An exchange trader moving funds between one custodial exchange and another custodial exchange doesn't really benefit from anything, any of those properties, because they're going to be in the custody of one exchange or another anyway. So there's basically, in other network technologies like internet technologies, there's typically layers that are optimized for different use cases. So I see that continuing to evolve in Bitcoin.
Yeah, I agree that hybrid solutions are what is really new about Bitcoin. Before I thought about the dualistic option between a fully trusted custodial layer on top of Bitcoin, the Alfini vision, if you may, and then there is like Lightning, which is almost completely trustless if you manage that properly. But the nice thing is that in Bitcoin you can have even more degrees in between. For example, with multi-sig technologies and stuff like check, secrets, verify, you can have very strange wallets in Bitcoin. Like you can have a wallet which for 1 year needs 2 keys to be moved. One is yours, one is the key of the service or the bank, which is a little bit like Blockstream Green works. So you get extra security, because if you get attacked or hacked, you cannot spend alone. But then for the second year, relatively speaking with CSV, you can spend your money alone without the help of the counterparty. Then for the 10th year, even if you lose your key, your counterparty can spend the money alone, so you can have like the last resort recovery service. So maybe this is, I mean, I just gave an example which is not optimal, but you can have a lot of middle ground, a lot of very complex custodial, non-custodial solutions that are trustless but trusted in some phases. Right now that's not trivial to do, because a transaction like that will be super expensive to spend on chain with a CSV and with different public keys. But with stuff like Taproot and Schnorr, you can actually compact very complex policies in a very small transaction, and that can open up a lot of hybrid models between custodian and not.
So I think we have a little bit more time. We have 2 minutes. So what new approaches, in your opinion, are interesting and worthy of exploring when it comes to scaling?
Sorry, the scaling future ideas. So, I mean, there are more, Lightning hasn't stood still. There's Lightning L2, which is more efficient and can benefit from Schnorr and Taproot in making the channel establishments smaller and indistinguishable from regular wallet spends. There continues to be a fast generation of new ideas in Lightning. Something else which more significantly improves scale for Lightning is this idea of channel factories, where many types of channels can be established and replaced off-chain even, so that there's sort of another layer to it. And that is estimated, I've heard, to be, provide maybe a 20 times lower chance of requiring on-chain activity. So those are kind of short-term things that people already know how to do. There are other models. So there's something called state chains, which has been proposed more recently. People are still thinking about what that implies in the security model, there probably are additional ideas that have yet to be developed about how to use this kind of, basically how to anchor the general programming. So you've got Bitcoin, which can be your sort of trust arbiter to anchor security, but leveraging on top of that, evidently with Lightning, it's possible to retain that property while not clogging up the chain with the transactions that are happening off-chain. So I would expect that it should be possible to do more things, and we certainly know it's possible with sidechain related technology if some new cryptographic techniques are made efficient enough to do more than that. So for example, you could have some more efficient future form of bullet proofs where the proof is actually that the whole sidechain's block validation was correct without needing to expose the main chain to the complex and new code, experimental code on the sidechain. So it's a way to sort of extend Bitcoin in modular layers without importing risk. And today, the way to do that has some kind of security reduction. But ultimately, if some of these zero-knowledge proof tech become more scalable and efficient enough to prove more complex programs, like the validation of a whole block, then that opens up a whole new possibility. And that area of research is progressing very fast. Every few months, there's some interesting developments.
Yeah, absolutely. Modular, right now, if you change Bitcoin, you have trade-off in Bitcoin. If you use confidential transactions or confidential assets plus ring signature, you get some scalability, privacy, but you give up scalability because they are big and slow. And if you get more flexibility with more opcode, like in Bitcoin, there was this op eval that was doing crazy stuff, very, very flexible, but then it was insecure. And Satoshi actually deactivated a lot of opcode in order to make it more secure. So you have trade-off between flexibility and security, privacy and scalability, and stuff like that. If you can, as Adam said, modularize things in different sidechain, you can experiment with trade-off without destroying the base uniformity of the monetary level, using the same kind of money. That would be great. What I think is that, scalability is very important, but it may have been instrumentally overblown during the recent debate, that it was over scalability, but it was mostly over control. So the point was controlling Bitcoin. As Adam said, it was not just the merit of the proposal, the problem. The problem was the method of the proposal, trying to take over an open source free experiment. So scalability is important, but privacy and fungibility are right now probably more important. And the nice thing is that layer 2 like Lightning are providing a new level of both, because when you move transaction off chain, you get more scalability, but also, if you make it right, more privacy.
Yeah, so another area where you can, so Giacomo mentioned op eval. So Bitcoin scripts at a much earlier stage had a little bit more flexibility, more opcodes and things. And the trade-off is if you add like full flexibility, you run the risk that you cause like a big failure in contracts that become too complicated to manage, basically. And we've seen a number of altcoins experiment in this direction and have some pretty spectacular failures. But multiple. So, yeah. So, but another direction for adding flexibility back in for extensibility and more full-featured smart contracting is simplicity, which is something that has been around since 2012 in its initial concept. So the MAST concept was initially about simplicity. So Blockstream has been working on simplicity in the last few years. Russell O'Connor has been developing that, and we released a developer release in the last few days. So we'll be adding that into Liquid next year, and eventually something like that, if there's consensus for it, could get implemented into Bitcoin, and it's designed to be Bitcoin compatible. And the interesting thing about simplicity is it brings extensibility to Bitcoin-like chains. So if you had the hypothetical that simplicity was in Bitcoin today, we wouldn't have needed opCSV, we wouldn't have needed so there are more things needed for L2 for Lightning. So it needs sig hash no input, so there'll probably be another soft fork for that. And we've also got there's also Schnorr and Taproot, which are coming. So all of those things would be directly implementable in a quite efficient and compact way using simplicity. So when you see new layer 2s being developed, they often, they kind of work, or they need a couple of extra opcodes to become possible. And so to get a new soft fork implemented and deployed takes like a year or two, right? So the idea that if you have a new idea and okay, you really need a Schnorr signature, or you really need a new SIG hash, that you could just code one up and run it immediately is pretty interesting for accelerating development and having less changes to the core protocol, because basically the core protocol becomes more final form, so that people can do these kind of extensions as needed basis. And Simplicity has a wide range of techniques for making formal proofs about the implementation of the functions that you use and their runtime. So it solves the kind of risk component that Giacomo was hinting at in terms of adding general extensibility. So it gives the general extensibility and controls the risk in a very effective, provable security way.
All right, I think we're at time. Thank you so much for joining me on stage. Thanks to the audience for sticking out the full weekend.